So, by far, one of the strongest pieces of evidence for my theory of quantum gravity is actually from particle accelerators, from proton proton collisions in particle accelerators. We find that electrons are produced in these collisions. And really, in physics, there's only kind of two answers that we can have to this, I think, really, when considering proton proton collisions and the production of electrons. And this is that since no electrons have gone into the reaction, if you like. It's just been protons put into the reaction. And we can think that in this reaction, it's the collision between two protons liberating an electron from the background. And this is really very often in what we're trying to do in particle physics experiments with particle accelerators and so on. We're trying to excite the background in some way such that we can then learn more about it. And there's numerous ideas that go around in physics trying to explain this production of electrons. They think it might come down to the production of positron electron pairs. That's one way in which an electron can be produced. Then there's the decay of beauty quarks into electrons or muons. And there's a couple of other ways which I can't really remember right now. But it's important to remember, I think, that we don't actually observe things like beauty quarks very well. We just observe them from their decay products, right? And this is very often something I think that physics kind of gets hung up on, this issue of what we're really looking at when we're looking into these particle physics experiments. And I happen to believe it's exactly the same kind of problem with the Higgs boson detection, that really when it comes to the Higgs boson detection, for example, we might not actually have detected a Higgs boson, because it's like this. Really, what could have happened is that two protons collide with one another. They collapse to form a naked singularity very briefly, and then the naked singularity almost instantaneously decays away to give two gamma ray photons. And it's really the gamma ray photons that we're detecting in the ATLAS and CMS detectors of the LHC. So really, we never observe things like beauty quarks, or we never really observe things like Higgs bosons. We just sort of infer their presence from the decay products of the reactions between protons and so on. And that's kind of what physicists are really doing with these particle accelerators. But yeah, it needn't be that. These phenomena can actually be explained, I think, by other means, and probably by simpler considerations. And really, when it comes to the emergence of electrons in LHC data and so on, yeah, I think there's a very good case it comes down to this this more, I hate to say it, I think rational and consistent approach to physics that I would propose, that yeah, explains it as the liberation of electrons from the background instead of the creation of electrons. I really, really, really struggle accepting any idea that particles are spontaneously created in any kind of high or low energy situation. I really struggle to see how that doesn't violate the principle of the conservation of energy. And the grand conservation principles, I think those do hold in nature. And I don't believe that matter can be created or destroyed. And I think that when you're kind of like probing new physics, and when you're taking physics to its most extreme uh, environments, if you like, with these very high energy domains we find in particle accelerators, I think that in the past too much esoteric, not esoteric, that's unfair actually, but yeah, too much kind of what am I trying to say? That a few bits of bullshit have slipped into our models. That's basically what I'm trying to say. I don't know. It's just it seems more logical to me. It seems like it doesn't violate any really key fundamental principle to think that Electrons are being liberated from the background as opposed to created in particle accelerators via these sort of elaborate means, such as the creation of beauty quarks or what have you. And I think it makes a lot more sense to consider that, for instance, the cosmological constant, it is not the creation and annihilation of photon-anti-photon pairs where they very quickly annihilate, and sometimes a photon is like left over after that, and this causes the expansion of space. I don't believe that. I really don't. I think it's just electrons tunneling around the universe, absorbing a photon in one location, tunneling to another location, releasing the photon again. So thereby we get some photons emerging in space that can contribute to the accelerating expansion of the cosmos. And via those means, we don't have to invoke the creation of matter, because we can't create matter. We have incredibly sophisticated science and engineering, but we can create antimatter, supposedly. Even though I have my own thoughts about antimatter, I don't entirely believe that antimatter exists. I believe that like something like antimatter might be more easily explained by the tunnelings of W particles through the background and so on. Then they get absorbed by a background electron, and the background electron emits a photon in return, and stuff like this. So we can have positron emission tomography and what have you. But yeah, I think it's a lot more physical to reduce our assumptions to the minimum possible number, follow Occam's razor, and in probing new physics, maybe taking more of a reductionist approach to entities such as the Standard Model, and not considering that there might actually be fewer particles than we really think there are, and trying to, because I think physics has come an extraordinarily long way, that incredible discoveries have been made, and it's just a matter now, I think, of paring it down, making it more beautiful, making it simpler, very possibly as well. And I think it will yield a great deal in terms of our understanding if we follow that path. But I don't. Yeah, I think really what the evidence seems to indicate, and a lot of evidence does indicate it, is that electrons play a very fundamental role in gravity. And I think that that is demonstrated, and I think it's an apposite feature of a cosmological theory to invoke particle accelerator data, and this fact that electrons routinely show up in proton-proton collisions. No electrons have gone into the system, but electrons have come out of the system. Where have those electrons come from? Very easily, I think they've come from the background of space. And I think that the energy from the proton-proton collisions has been sufficient to liberate a few electrons from the background. And yeah, I think I'll happily use that as a piece of evidence for my theory of quantum gravity, and along with many other pieces of evidence, I think, or you know, facets of nature that are well observed and well studied, that yes, seem to point in the same direction. So yeah, that's roughly what I have to say, I think, for this video about particle accelerators and evidence for my theory of quantum gravity. Thank you everyone for watching. Bye bye bye. Love you lots as usual, and I'll see you all soon.